I did field service before they said you talk too much, you should sell stuff. I did field service for 17 years, and one of the things I did was transmitter installs, training, commissioning, and repairs. I crawled through them at 3 in the morning. I flew to Western Canada from Halifax, so about 6 hours, 8 hours of travel time, and a 3-hour time change. So by the time I get there, it's 2 p.m. Halifax time, but it's only 11 in the morning Calgary time, so we go to the transmitter site. All right, I put in 8 hours just getting there. We go to the transmitter site. We start to commission the transmitter. We get it up, we get it running. It's making 50,000 watts. We're going to do a little bit of training. I've got 12, 13, 14 coffee in me at this time. I'm practically vibrating from the caffeine. And we're doing training. And I said, the great thing about this transmitter, it's got dual exciters. If the main exciter fails, it'll fault to the standby. And I pulled the crystal out of the oscillator on the main exciter. Sure enough, transmitter dumps, tick, 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 over to the standby, right back up. And I said, but it's a one-way, one time, because it figures you got to come in and fix it, so it won't switch back. And I pulled the crystal out of the B exciter. Transmitter dumps. Nothing happens. It stays dumped. I said, see, it won't go back. I said, the only way to bring it back is to select an exciter. So I select exciter A, and then I realize the crystal's out of exciter A, so I reach out and plug it in as the transmitter tries to come up on exciter A. You know what? Crystals don't come up on frequency. I don't know what frequency it tried to come up on, but the transmitter made a squeal, sort of like a pig run through a blender. And we blew 127 MOSFETs that night.
Wow.
It's 2 o'clock in the morning now. 5 o'clock in the morning Halifax time. I'm pushing 24 hours on my feet. Now we're going to start fixing it. All right? We blew ballpark about $10,000 worth of parts because I was too tired to be working on the equipment. All right? It happens. Doesn't happen anymore because now I look at the watch, 16 hours, I'm done. You know, learn when your tired time is. There's nothing, well, they say nobody ever died because of the lack of rock and roll. But you sure can blow up equipment and yourself if you get working and you're too tired to be fully able to pay attention to what you're doing. Okay, this stuff's not something you want to be messing around with without focus. All right, there's obvious costs associated to all this stuff. Well, number one, like I say, I cost the company $10,000 in warranty parts. I cost them another $3,000 in the travel time because I was at that site an extra 2 days fixing all the stuff I blew up. On the other hand, the customer got really good at troubleshooting, so that was an actual benefit. All right, over and above that, there was a cost of a couple $1,000s for the stuff that I wasn't doing while I was over here fixing the stuff that I shouldn't have blown up to begin with. So it all adds up. The only thing, we were very lucky, nobody got hurt. And I was very lucky the customer had a good sense of humor. Is anybody familiar with those symbols? I know you can barely see the one on the right. This is tab off a sneaker, it's an ohm sign. If you see a pair of shoes with that ohm symbol on them, it means they're electric shock resistant rated. What that means is that they will handle a potential between the sole and the inside of 18,000 volts for 1 second without passing more than a milliampere current. Those shoes are available for $69.95 at Walmart. I know because I looked it up yesterday. And they're available at every Walmart in this immediate area, in stock. And they will save your life when you get across something stupid. Now, I say this immediate area, I mean Meridian, but it's all relative, right? Anyway, I'll give you another war story. Working on an oil rig in the Persian Gulf because back in the service days, you didn't get to call where you went to work. And we're doing an install on oil rig locator beacons, low frequency transmitter into a very short whip, which is incredibly inefficient, 75-foot whip, only about 50 watts, but it's right about where Bo is. And I'm standing there leaning on the scaffolding that's bolted to the rig deck, because the funny thing about putting oil rigs into saltwater is that they need to be painted constantly. So they're always bolting scaffolding on and painting stuff and moving the scaffolding. And I'm leaning there on the scaffolding talking to the local engineer, and he puts his arm up and leans on the scaffolding and jumps back with a good chunk of skin missing. RF burned. The scaffolding was hot. I was wearing my shock-resistant shoe. I didn't even notice. All right, that's the difference that 69.95 makes. Anybody ever got an RF burn besides me? I'm going to say, I know if Mike and Bo didn't put up their hands, I was getting ready to walk out, because at that point you just vivid. These will make a difference. All right, 5 kilowatts when it goes in through your wrist and comes out through your hand hurts. RF burn will keep on hurting for quite a significant while. And the funny thing is, the RF burn's not always what hurts so bad. It's the damage you do when you jerk your hand back or jerk your head up and catch it on the back of the cabinet and split your skull open. All right, it's getting away from the RF burn that sometimes hurt more than the burn itself. Is everybody familiar with those? Especially if you work AM or any tube-type FM rig, you had better be familiar with those. Everybody knows the grounding stick.
Use a stick.
Because if you don't use it, you'll need them. Right. All right. If you don't have one on the transmitter site, a wooden broom handle, a roll of duct tape, and a set of booster cables out of the back of your truck will rig you a grounding stick in about 5 seconds. Easiest thing in the world to create, most underused thing in radio, especially at sites. If you're working on an ATU, one more war story. Now, there'll be more war stories than one, but we'll stick with one for right now. Customer in Paraguay, putting in a new transmitter, got a 200 kilowatt, got it up, got it running, got some arcing going on out of the tower, so we shut the transmitter down. And we're going out to take a look at the base of the tower, see if the ball gaps are set too close, anything like that. Customer's engineer leans against the tower. Tower's not grounded at this point. Now we know we're shut off, and our transmitter's grounded because I locked it up. He touches that tower, and we end up calling 911. Because what we didn't know was that the 100 kilowatt transmitter 2 miles away wasn't shut off. All right? Quarter wave stick will receive as well as it will transmit. It doesn't care whether the signal's going that way or this way. So you can't rely on your signal being the only one that antenna's picking up. If you're doing any work on the ATU, you ground that tower. Is anybody familiar with the term arc flash? How many 50 kilowatt AMs do I have in here right now? Couple? How many FMs do I have with a TPO at